welcome to another in the ARM What Is Program series. In each episode, we explore a tech topic to give you insight and perspective into some of today's hottest design trends. I'm Brian Fuller, Editor-in-Chief at ARM, and today we're going to find out what is heterogeneous compute. And to help us with that, I want to introduce Erik Jacobson, Marketing Director, Architecture and Technology with ARM. When he's not helping us understand what is heterogeneous compute, Erik spends time learning new things from his two fabulous daughters. So let's dive right in. So Erik, what exactly is heterogeneous compute?
It's really about using additional processing elements above and beyond the classic one or multiple core CPUs, whether it's GPUs, NPUs, SmartNIC, various combinations of accelerators. And then taking that combination or designing a combination that is optimized for a very specific use case. And on top of that, making it programmable. So instead of having accelerators you can't actually get to, making it, as a developer, really easy to use. So it is about taking that system level approach, having these different types of processing elements in there and making them accessible. It's shifting from just a CPU or heavy CPU-centric to this much more heterogeneous approach.
Yeah, so you mentioned that the CPU used to be the superstar of any system, and now we're in a period of diversification. What's driven that?
So the easiest answer to that is Moore's law, right? Hey, Moore's law is coming to an end, But actually, there are other market forces at work here. A big one, for instance, is verticalization, where companies are taking more and more responsibility up and down the stack. And the reason they're doing that is to get more control. So if you're building your own SoC, then you're clearly going to optimize for the workloads that you need to run. And that's a different, very different world from looking around from what's on the market and just buying off the shelf SoCs. So there's that market trend. And there's another market trend, which is just that some of these software stacks have so much investment in them that actually the days of customizing software to run on hardware are probably gone. And now it's about software driving new functionality, and then you designing the hardware afterwards, because the software has many years of investment in it. So to run an existing software stack, you need to maximize the performance of the hardware to run that on. So it's not just about a technology or technological reason, it is about market forces as well.
Can you talk a little bit more about how designers can mix and match various compute engines to optimize their systems?
The main thing is to pick the best tool for the job, right? And the job is the workload, and by the workload we mean, basically the process and data. What's the system going to be doing? What's it going to do? What are you optimizing for? Is it the classic power, performance, cost? You might be running similar types of workloads, but in different environments. The designer has to know about the workload and the constraints. So the days of, we'll create hardware and have lots of different software running on it, what heterogeneous compute does is saying, well, actually, there are a lot of really mature software stacks out there. We need to run it with the best performance or lowest power or on the cheapest components in this location, And so then the designer maybe has to model that, has to understand, running it through various models, etc., what the best trade-offs are, and design their system appropriately. There are various, in fact, we have various specifications like AMBA and the SystemReady program, which ensure functional compliance, that it works. So SystemReady, for instance, is about an operating system working out of the box. But the hardware designer then has to go off and say, well, actually, I'm going to change these elements in the hardware. It's still going to work, but I'm going to squeeze out that extra whatever performance.
Is heterogeneous compute being applied in a few application spaces, or is it more broadly deployed than that?
CPU and GPU combination has been around a long time, really, and that's pretty much a heterogeneous compute method, although maybe accessing the GPU isn't quite as easy, or rather a different form of programming of it. I think there's still a lot of, we haven't come to the end of CPU-centric at all, but I think we will see more and more heterogeneous. I think where we're seeing it is where there are constraints or where there's quite a lot of money in it. So for instance, if you are running a large server farm, let's say, obviously there's a lot of budget to be saved in power, whether it's from air conditioning or just the actual base load. Other areas, existing CPU systems are perfectly fine, and there's no reason to change them. The cost, power, performance, those three are perfectly fine for those areas.
Well, thanks, Erik. It's stunning to see how innovation at the processor level is taking the electronics world to new heights. Now, check out all our other What Is episodes here, and be sure to subscribe to this channel because we'll be adding more as the year progresses. Thanks for listening.